Today we're going to talk about counting numbers, specifically counting numbers in chemistry. We're going to start by talking about counting numbers that you may already know. And I have some pictures up here that you may be familiar with. This first one on the left-hand side shows you 1 dozen cupcakes. And that equals 12 cupcakes. This is a value you're probably familiar with and you use regularly. If you go to buy eggs, you're not going to buy 1 egg, you buy a dozen of eggs, you can buy a dozen donuts, you can buy a dozen bagels, and you just know that that is going to give you 12 of that item. In the middle, we have 1 pair of shoes, and that equals 2 shoes. The very end, this might be one that's new to you. This is a gross. It's 1 gross of roses. It's a larger counting number. It is, in this case, roses, and so a gross is 12 dozen, which is 144. Another counting unit you may know about is a ream. Paper comes in reams, and that's 500 sheets of paper. Now, none of these counting numbers work for us in chemistry because we're talking about particles that are really, really small. And so atoms, molecules, formula units. So we need a counting number that is larger than that. And so what we use is Avogadro's number. Amadeo Avogadro came up with this number, and it is called the mole. The mole is an amount of a substance that contains as many particles as there are atoms in exactly 12 grams of carbon-12. And so 1 mole, if you have, and you're going to memorize this number just like you memorize a dozen, is 12. 1 mole of anything is 6.022 times 10 to the 23rd particles. And so if we're talking about a mole of copper, copper is in our phenomenon. So if we have 1 mole of copper, that is equal to 6.022 times 10 to the 23rd atoms of copper. If you have a mole of iron, the other element in our phenomenon, 1 mole of iron is 6.022 times 10 to the 23rd atoms of iron. So we can use Avogadro's number, the mole, to do conversions. So in our phenomena, we want to end up with how many atoms of copper are produced and how many atoms of iron is used up. And so we can't count each individual atom of those substances. We can't count every copper atom or we can't count every iron atom, but we can do some conversion. So we can do a mole to particle conversion. In this case, our particles are atoms. And the conversion factor we're going to use here is Avogadro's number. Now you do need a calculator to do this. We're going to go through, set up the problems, and then solve it, and I'll explain how to use your calculator again. So how many moles of copper are in 2.55 times 10 to the 22nd atoms of copper? So we're starting with 2.55 times 10 to the 22nd atoms of copper. And we're asked how many moles of copper do we have. Now, just like we did with the metric system problems, the metric conversions, the density problems in Chapter 2, you're always going to start with the number in units given when you start the problem, the top of your railroad track. So 2.55 times 10 to the 22nd atoms of copper. And you're going to put a 1 underneath that for a placeholder. The units that I'm given in my problem, I'm going to drop down to the bottom of my first conversion factor. And then the units I'm looking for, moles of copper, will go at the top. So you can see the only number I've put down is the number that I started with. I don't put any other numbers in. I just set up my units. I look at the units in my conversion factor. They're moles and atoms, which is Avogadro's number. That 1 mole of copper is equal to 6.022 times 10 to the 23rd atoms of copper. I'm going to go over how to plug this into your calculator. So you remember that when you solve your railroad tracks, your dimensional analysis problems, you multiply the top, you multiply the bottom, and then you divide. You do need to round for correct units or correct sig figs at the end and include units. So when you're doing this problem on your calculator, you're going to type in 2.55, and then you want to select the second button, and then go down to the x to the -1, so that your calculator reads 2.55e, and then 22. Do not put in a caret. Do not put in a times 10. It should just read 2.55e22. And we've done these conversions before. When I multiply across the top here, I'm going to get 2.55 times 10 to the 22nd. Multiply across the bottom, I'm going to get 6.022 times 10 to the 23rd. So I'm going to divide these two numbers. And you can kind of see my calculator. I don't have any carets, any times 10. I use the E button. So 2.55e22 divided by 6.022 e to the 23rd. Hit enter. And then we need to round for correct sig figs. So the number we were given has 3 sig figs. Avogadro number has 4 sig figs, so I should round for 3 sig figs. So I would get 0.0423. These units cancel, and I get moles of copper. And that's my final answer there. We're going to do one more example. So in this example, we went from atoms to moles. We're going to do the next example. We're going to go moles to atoms. So here's the next problem. And so, again, when we convert from moles to particles, we're going to use Avogadro's number. And so I'm starting with 0.345 moles of aluminum. So I'm going to start with my number here. Number in units I was given in the problem. Put a 1 as a placeholder. The units that I was given move down. And then we're asking to convert to atoms of aluminum, which will go up here. And again, I did not put any numbers in my conversion factor yet. I'm not memorizing when I multiply or I divide. I'm simply setting up my units so that I can convert from a quantity I'm given to a quantity I'm looking for. My units are atoms in moles, which is Avogadro's number. 1 mole of aluminum equals 6.022 times 10 to the 23rd atoms of aluminum. You're going to multiply across the top, multiply across the bottom, and divide. In this case, we were dividing by 1. So I'm going to multiply across the top. And when I look at my sig figs, I have 3 that I started with, 3 sig figs when I started, 4 in my Avogadro's number, so I should have 3 sig figs in my final answer. So it would be 2.08 times 10 to the 23rd. These units cancel, and I'm left with atoms of aluminum. You have practice problems to do, and then we will go over them the next day in class and take the daily assessment over them. We'll go over them before we take the daily assessment, and then you can use them on your daily assessment as well.